The Wooden Wonder, the impossible legend of the de Havilland Mosquito. In 1940, the British Air Ministry rejected a warplane before it ever left the drawing board. Too fragile, they said. No guns, no armor. Built, of all things, out of wood. The same material as a kitchen cabinet. 2 years later, that aircraft was the fastest operational machine in the sky. Faster than the Spitfire. Faster than anything the Luftwaffe could put into the air. The Germans hunted it for 5 years. They rarely caught it. This is the story of the Mosquito. The aircraft the Air Ministry didn't want, built by carpenters and cabinet makers instead of riveters and metalworkers, that went on to become one of the most feared weapons of the Second World War. And by the end of this film, you'll understand why some of the greatest engineering triumphs in history don't come from more armor, more guns, or more steel. Sometimes they come from taking everything away. The unarmed anomaly. By the autumn of 1939, Britain's bomber command was facing a crisis it could not admit out loud. Its bombers, heavy, armored, bristling with defensive turrets, were dying in the sky at a rate the country could not sustain. Every mission sent young men into German airspace inside aircraft that were, in truth, slow-moving targets, wrapped in steel that was supposed to protect them, but mostly just weighed them down. Into this atmosphere of quiet desperation, Sir Geoffrey de Havilland made a proposal so unconventional that most of the Air Ministry assumed he was joking. Build a bomber with no guns at all. While every other designer in Britain was adding weight, thicker armor, heavier turrets, more crew to man them, de Havilland wanted to strip it all away. His theory was almost insultingly simple. If an aircraft was fast enough, it wouldn't need to survive a fight. It would never be in one. Remove the turrets. Remove the 4 or 5 extra crew members needed to operate them. What's left isn't a fortress anymore. It's something closer to a fighter jet with a bomb bay, a warplane whose only defense is that the enemy can't catch it in the first place. It was a radical bet, and almost nobody in the Air Ministry was willing to take it. Chapter 2. Rejected, then built anyway. The ministry's response was blunt. They shelved the project, filed it away as an eccentric relic of pre-war thinking, in a moment when Britain believed the future belonged to heavier, better armored machines. It should have died right there. Most projects do once the government pulls its support. But de Havilland didn't stop. He moved the entire operation, quietly, using his own money, to the grounds of a country manor called Salisbury Hall, far from the prying eyes of Whitehall, and there, away from the bureaucracy that had rejected him. The project that would become the Mosquito began to take shape in secret. Here's the detail that makes this story remarkable. Building a frontline warplane out of wood in the age of the Spitfire wasn't just stubbornness, it was a brilliant strategic workaround, one that solved 3 problems Britain's aircraft industry was drowning in, all at once. First, speed. Wood could be shaped and assembled far faster than the complex metal tooling required for aluminum aircraft. Second, supply. Every scrap of aluminum in Britain was already being fought over by the Spitfire and Hurricane production lines. Timber came from an entirely different supply chain, one nobody else was competing for. And third, labor. Building the Mosquito didn't require riveters or sheet metal workers, who were already stretched thin across every other factory in the country. It required something Britain had in abundance: furniture makers, cabinet makers, piano builders, skilled tradespeople whose peacetime work had nothing to do with aircraft and everything to do with precision woodworking. While the rest of the nation was tearing down garden gates and iron railings to melt into Spitfires, the Mosquito was being built with sawdust instead of sparks. But building it out of wood raised an obvious question, one the skeptics in the Air Ministry weren't wrong to ask. Could a warplane made of plywood and glue actually survive combat? Could it possibly compete with the metal fighters already ruling the skies over Europe? And the answer, when it finally came, stunned everyone who doubted it. And it starts with how this aircraft was actually put together, because the engineering hiding inside that wooden fuselage was more advanced than almost anything flying in 1941. Chapter 3. Engineering the impossible. The man responsible for turning de Havilland's radical idea into an actual flying aircraft was designer Ronald Bishop. And what he built was not in any meaningful sense a wooden airplane in the way people imagine. It was a composite structure that rivaled the best metallurgy of its era. The fuselage was built as a balsa and plywood sandwich, thin sheets of veneer molded over giant jigs shaped like the hulls of upside-down boats, bonded together with glue derived from fish protein. 2 curved halves, joined down the center, formed a single lightweight tube stronger than most people would believe possible. 2 Rolls-Royce Merlin engines, the same engines powering the Spitfire, were bolted onto an airframe that weighed a fraction of what a metal bomber weighed. That alone would have made it fast, but there was a second advantage almost nobody had anticipated. Metal aircraft of the era were covered in thousands of rivets, small metal pins holding the skin to the frame, every one of them creating a tiny amount of drag as air rushed over the surface. The Mosquito had none of that. Its wooden skin was smooth, seamless, molded rather than fastened. Engineers call this a slick aerodynamic profile, and in practice it meant the Mosquito sliced through the air with almost none of the friction that slowed down its all-metal rivals. When the prototype was finally tested at Duxford in 1941, test pilots couldn't quite believe what they were flying. Compared even to the Bristol B-Fighter, considered at the time one of the finest combat aircraft in the world, the Mosquito felt like a different category of machine entirely. Pilots described it as an outright joy to fly, with the agility of a single-engine fighter despite having 2 engines in a bomb bay. It could outrun a Spitfire Mark V at virtually any altitude. Think about that for a moment. A bomber, unarmed, built by carpenters, made of glued plywood, could outrun Britain's most celebrated fighter aircraft. Chapter 4. One aircraft, 1,000 missions. What happened next turned the Mosquito from a fast bomber into something closer to a Swiss Army knife with wings. Its raw speed and structural strength meant it could be adapted, again and again, into roles nobody had originally designed it for. Historians consider it the world's first true multi-role combat aircraft. As a bomber, the B Mark IV, it carried a 4,000-pound bomb load. That's the same payload as a 4-engine B-17 Flying Fortress. The Mosquito needed a crew of 2 to deliver it. The B-17 needed 10. As a night fighter, it carried early radar and a devastating nose-mounted arsenal, 4 machine guns and 4 20mm cannons, hunting German bombers in total darkness. As a fighter bomber, it carried that same firepower into daylight raids, and remarkably, all those extra guns only slowed the aircraft down by around 15 knots. And as a photo reconnaissance aircraft, stripped of weapons entirely, painted sky blue to vanish into the horizon, flew at 35,000 feet, faster than 400 miles per hour, photographing occupied Europe from an altitude German fighters could barely reach, let alone intercept. This wasn't blind, indiscriminate bombing from 30,000 feet. This was surgical, personal, an aircraft built by carpenters delivering precision strikes that terrified the Gestapo command structure itself. Chapter 5. The Nemesis and the Sunset of an Era. For nearly 2 years, the Mosquito lived up to its reputation as functionally uninterceptable. But no advantage in warfare lasts forever, and by late 1941, Germany had an answer. The Focke-Wulf 190, designed by Kurt Tank. At medium altitudes, for the first time, a German fighter had the speed to actually challenge the Mosquito. The gap that Wood and clever engineering had opened began slowly to close. And then came a threat that made the FW-190 look almost quaint. The Messerschmitt Me-262, the world's first operational jet fighter, signaled the true end of the era the Mosquito had ruled. No amount of clever aerodynamics could outfly the raw thrust of a jet engine. The age of piston-powered speed, the very advantage the Mosquito had been built around, was ending. But even here, the Mosquito had one last trick nobody had planned for. Because it was built from wood rather than metal, it reflected far less of the radar signals German defenses relied on. Almost by accident, decades before the word existed in common use, the Mosquito had stumbled into something close to stealth technology. Even as its combat career faded, the design proved so sound, so reliable, that the Mosquito kept flying for another decade, training the very jet pilots whose aircraft had finally caught up to it. The legend of Sawdust and Merlins. Between 1940 and 1950, 7,781 Mosquitoes rolled off production lines across Britain, Canada, and Australia. It remains one of the most remarkable engineering stories of the Second World War, not because it used the most advanced materials available, but because it proved that the most advanced materials aren't always the ones that win. Total production, 7,781 aircraft. Top speed, 400+ miles per hour. Combat loss rate, the lowest of any aircraft in Bomber Command. Sir Geoffrey de Havilland's Gamble, an unarmed bomber built out of what the Air Ministry once dismissed as furniture, went on to record the lowest loss rate of any aircraft type in Britain's Bomber Command's entire war. Not because it had no guns, because it had no guns, and everything that weight would have cost was spent on speed instead. History remembers the Spitfire, it remembers the Lancaster, but it should remember the Mosquito just as clearly. The aircraft nobody wanted, built by hands more accustomed to shaping chair legs than airframes, that went on to outrun the fastest fighters of its day, and terrified an enemy that never quite managed to catch it. Sometimes the most advanced piece of engineering in the sky isn't the one wrapped in the most steel, it's the one that had the courage to carry none at all. See you in the next video.
With the undercarriage damage, many a Mosquito landed on its belly, a cloud of dust and gas from automatic fire extinguishers. With the main entrance blocked,